Alright, so we're finishing up the last problem on notes 11.4 about classifying conic sections. And so when we're looking at this, the first thing that we want to establish is what kind of conic is it, so we have an idea what our destination should look like. What kind of equation should this look like once it's in standard form? And so unlike in number 7, where we had our coefficients of A and C were 9 and 4, and they were both positive, on number 8, they are 9 and -1. So they're opposite signs for both of those x squared and y squared terms, which makes this a hyperbola. So we're going to go ahead and identify that this is a hyperbola. We don't know the orientation just yet, and we really won't know it until we get going. So we'll come back to that at the end. But we do know we're going to have something that looks kind of like that ellipse equation, except subtraction instead of addition between the x squared and y squared terms. Okay, so we're going to go ahead and sort of separate these things. So I'm going to start with my x squareds. And so I'm going to bring 9x squared minus 36x plus blank. And then I'm going to do the same thing over here with my y's. So I've got -y squared minus 6y plus blank. And then we are going to go ahead and subtract that 18 over to the other side. And then we're also going to leave a space to add to complete the squares for the x's and for the y's. All right, so on that first one, I'm going to get started by factoring out that 9. So x squared minus 4x plus blank. We still haven't established what that is. And let's finish that one out. So I'm going to go ahead and complete the square. So I'm going to put a binomial squared. And then the number that goes in there is going to be half of the b value above. So half of that -4, that's going to be -2. -2 squared is +4. And then we don't put a 4 here. We have to do 9 times 4. So you can write 9 times 4, or if you'd rather, you could just say 36. Now I can't just add to the left without adding to the right side of this equation, so I'm going to add 36 over here. Alright, so this is a little bit of the tricky part. You might think, oh, there's nothing to factor out on this, but we don't want anything in front of that y squared, not even the -1 that's there. So I'm going to go ahead and factor out a -1 or a negative sign. And then that becomes y squared plus 6y plus something. Okay, so I'm going to go ahead and just complete the square for those y's. So we're going to take half of that b value in that quadratic, and that's going to be +3. Because half of 6 is 3. 3 squared is 9. Now careful, you got to be careful here because we're not going to put 9. Remember, we have to take whatever we factored out and multiply it back. So that -1 times 9. So that's actually going to be a -9. And then we've got everything ready to go on the left. We've just got to combine what we've got here. So I've got -18 plus 36 would be +18. And then +18 take away 9. That would be 9. Okay, so all we're going to do now is hyperbolas ought to be set up so that we have them equal to 1. So I'm going to divide everything by 9. And so then those 9s both cancel out over here. They both become 1s. And then nothing reduces here. It's like there's a 1 there. I can't reduce that with the 9. So I'm going to go ahead and write my final equation. It's going to be x minus 2 squared. And we'll want to keep the over 1 because that's going to help us identify our a value. And then minus y plus 3 squared over 9 equals 1. All right, and so I can see that my x term is the leading term. So that means this one is going to be horizontal. And I'm going to go ahead and write that over here. So x minus 2 squared over 1 minus y plus 3 squared over 9 equals 1. So our job at this point would be to go ahead and graph these. So I'm going to go ahead and graph this hyperbola while we're right here. I can see that my center is at 2, -3. So over 2 and down 3. And then my a value, right, so this is a squared, this is b squared. So a is going to be 1, b is going to be 3. So in order to graph that, all I need to do is understand that this is horizontal, so I'm going to move horizontally a units. So 1 to the right, 1 to the left, and then I'm going to go up 3 and down 3. And then we're going to make a rectangle, and then we'll use the corners of those rectangles to go ahead and graph our asymptotes. And then it's horizontal, so our vertices are to the right and left of our center there. And then we're just going to kind of make that so that it approaches those asymptotes but doesn't actually touch, but they become sort of boundaries or guidelines. So that's how we graph that hyperbola. Now in class we didn't graph the others, so I'm going to kind of review those because I asked you guys to do that in class. So we'll just work our way back up the notes. Here we've got an ellipse, and our center is -2, +3. So left 2 and up 3. Now this is an ellipse and it's vertical, and so our a value is always larger. So that 9 in the denominator of y minus 3 squared, that's a squared. So a is 3, so that's the square root of 9, and b is 2. And then this is vertical, so I'm going to go up and down a. Those are my vertices. Right and left from center, b units. And then that's our ellipse. So we're just going to connect that. And that's everything we need. Okay, so let's go and look at the circle that we didn't quite get to. Circles graph pretty quickly. We're just going to identify our center. And that's going to be 2, -1. So over 2 and down 1 for my center. And then just be careful, our radius isn't 9, because that's r squared. So our radius is 3. So we're going to go up and down 3, right and left 3, and then connect those. And then the last one we're going to graph is going to be that parabola that we didn't get to. So we established when we were completing the square that it was left-right, but based on this equation and the fact that the parameter is going to equal 1, because we take this, and that's 4p. So parameter must equal 1. And so what we're going to do is use that to say that this opens to the right. So our vertex, which is kind of like our center on everything else, our starting point, is -1, 2. So that's right up here. And then since our parameter is 1, then we go 1 to the right. Like this is our GPS. This tells you the direction, this tells you how much. That's where the focus goes. The directrix goes on the opposite side. And so the vertex should always be halfway between the focus and the directrix. And then to plot the endpoints of our lattice chord, we just use the parameter and we go up 2 times the parameter, so up 2 and down 2. When we've plotted those points, it should be whatever this value was here. It should be 4p units long. Now I just connect these to the vertex, and those 3 points are all we need for our graph.